Hello all, so this is Rahul here. So today we'll continue with the placement preparation series 2023 with the operating systems topic. So in the last class we talked a lot about operating systems, we talked about what is operating system, what are the goals of operating system, what does the operating system is gonna do, and we also talked a lot about memory structure, interrupt which is gonna happen inside operating system. Followed by that, we talked about the computer system architecture, computer system operations, and the multiprocessing tips, multiprocessing things too. Right. So just give you an overview. We talked a lot about it, and if you want to see the previous video, I'll tag that. Just go and see the previous video about what operating system is all about, and just give you a glimpse about all those things what we have seen in the last class. So today we're going to continue with the first unit of overview of operating system. So first, today we're going to talk about the operating system structure. So the structure of operating system. So far we learned about the computer system structure, and right now we're going to get into the operating system structure. So what are those things? I'm sorry. So what are those things? So there are two types. First is all about multi-programming, and next is all about time sharing. So as I already said about multi-programming is nothing but batch systems. So where we already talked about multi-programming in terms of multi-processors. Am I right? So why? Because in terms of using of single processor, we converted that into multi-processor. And what are the advantages of converting a single processor from a multi-processor? We talked about three different points. One is all about throughput. We talked about what throughput is all about. We said that the throughput is going to be high. Secondly, we talked about there's going to be an ease of scale, right? The scaling of multiprocessor is comparatively lesser in cost, comparatively lesser in cost than the construction of more than one single processors. Then thirdly, we talked about then thirdly, what is the thing is reliability. If one of the processor cannot able to do the job at particular time due to that failure, the other processors which is present inside the same chip can able to do the process or share the particular process. So we also talked about these things. As I want to say that these things we have already seen those things, and let me up this thing. Then based on this, we can also talk about what is multiprocessing. Multiprocessing is. I'm sorry. So single user cannot keep CPU and IO devices busy at all times. Am I right? Yes, we can able to say that thing. Single user cannot make keep the CPU and IO devices busy at all times. And multi-programming organizes jobs, codes, and data. So CPU always has one to execute. And subset of total of jobs, the system is kept in memory. Once job is selected, run via job scheduler. Very, very important thing, guys. But because we so far so good, we haven't seen any algorithms in terms of operating system. Why? Because just an overview we have seen about what operating system is all about, how the system structure is being done. So once let's talk about it. So what is going to be batch system? What is going to be multi-processing system? Let me just give you an overview about it, right? So let's discuss that. So the main part in so the main part in what can I say? Multi-programming is all about job scheduling. So the main part in multi-programming is all about job scheduling. Why I'm precisely saying about job scheduling is, if I want to talk about that, if I have more than one jobs, right? If I have more than one jobs, I'll make sure to put it in a queue. Like you guys know about what queue data structure is all about. So I'll just put it in my queue. Job number one, job number two, job number three, job number four, job number five. Like this, I'll put it in my queue and make sure that which of the job has been occurred first. I'll allocate the resources to the job and I'll start doing the job. After doing the job, the second most will be coming. The second most will be coming, and I'll start doing the job. And the next, after completing the second job, then the third job will be coming out, and the fourth job, and the fifth job. So one after the other. The first come first serve thing will be happening over here. So this is what multi-programming is all about. If at one time all the five programs are going to be giving a particular subset of total of jobs has been selected, and so what we are going to do, we are make sure to have a kind of data structure like queue, put it inside the queue, and based on the first come first serve and based on the priority algorithm what we're going to do, there are a lot of job scheduling algorithm what we have. Based on the algorithm what we choose, that particular job has been selected and used at particular point of time. Clear? Then, when it has to wait for an IO, when it has to wait for IO example, OS switches to another job. So let's talk at an instance. So let's say for process number one, if a job number one has to wait for IO, that means my input output cycle to get implemented. So for IO to get IO cycle to get implemented. So what's the main cause about it? The main cause all about it is nothing but it has to wait until that IO, that means the input output has been allocated for job number one. So it has to wait until the input output hardware or input output hardware or any other hardware like memory or RAM, ROM, etc. to be allocated for the job number one. So unless until it has been allocated, the job will be stopped. So that to make sure that it runs in a particular way and to have an higher throughput, what happens is nothing but for allocating those resources, like for instance, if an input output should be allocated for job number one, then it has to wait until input output has been allocated to job number one, but the OS will not stand by with this job number one. It switches to job number two, complete the job number two, unless until the waiting for time period for input output of job number one is being clear. Yes, so that's all about multi-programming. Then what is all about time sharing? So time sharing is also called as multitasking. So I want to give you an extension about how this thing is. So time sharing is nothing but when, as I said, the same thing, right? If like when the CPU switches jobs so frequently that user can interact with each job while it is running, create an interactive computing. That let's talk about that. If I have a set of jobs like one, two, and three, if I'm gonna what they say, frequently switch the jobs. Why? Because I don't want to wait for job one to be completed, and because if job one has any other input and output devices to be get recognized, so it has to wait for a while. But because the input output is not free, but so the OS will not wait, right? The CPU will not wait for the job number one to get completed, and that was to wait until the input output has been allocated. What happens is nothing but the CPU will switch the job to number two, right? So this is how the time can be shared. Why? Because this is how the time can be shared so that we can able to efficiently use the resources, efficiently run the jobs to create interactive computing, right? So and based on that we also summarize some of those things. The response time, the response the response time should be less than 1 second, and each user has at least one program executing in memory. That is the process. We'll talk about what process is all about. Process management is a huge consequence. Okay, in unit number two, we are going to learn a lot about process and the management. In several jobs ready to run at the same time, the CPU scheduling will come. There are a lot of CPU scheduling algorithms like first come first serve and a first come first serve algorithm, priority based algorithm. There are a lot of things, round robin, etc. So you are supposed to know each and every algorithm so that at what case these algorithms is going to help for us. That's the main cause. And if process don't fit in a memory, swapping may move them in and out of memory. That's very important, guys. We'll talk about that swapping. Why? Because you'll have two types of memory. Why? Because the memory, one of the memory which is being which is being associated with CPU, and one of the other memory, the external memory, which is available outside the CPU. If the space which is present, which is being associated with CPU is being filled, and we can't able to store any other processes, then what happens? Nothing but the processes which is already stored inside RAM has been moved from this memory to the next secondary memory. right? So virtual memory, so this is what the concept is all about. And virtual memory allows execution of process and do not complete in memory. Clear? Clear what the operating system structure is? Yes. So let's talk about the memory layer of the multi-programmed system. As I said, so this is gonna be our operating system, and we're gonna have job number one, job number two, job number three, and job number four. So as I said, for each and every job, we'll have some of the priority-based things. Why I'm saying priority is nothing, but the priority can be of any other types, like the priority can be based on the time. Yes, the time needed to complete the job, by because if the time is less, that job one can be completed as first, and or else they can also be have other characteristics too. So while we are seeing the scheduling job concepts, we'll talk a lot about that. Okay, characteristics too. It can also have other characteristics, right? Based on the first come first serve, they can also be prioritized. Clear? So this is how for multi-program system the memory layout has been done. Okay, then operating system operations. We talked about the structure of an operating system, right? We talked about what multi-programming is all about, like having a lot of jobs, how to schedule the job, and we also talked about time sharing, like scheduling the job, or we also talked about one more important concept like the CPU scheduling process, wrapping, and virtual memory too. Now, what is gonna be our operating system operation? I want to give you an overview about what is all about the operating system operation is. The first and foremost thing we're gonna talk here is interrupt driven, right? We're gonna talk about that is interrupt driven. Why? Because we already said that operating system is an interrupt driven. Interrupt driven in such a way that we can't able to say that interrupt will not happen at any other point of time, right? So interrupt will happen. So there is a possibility to there is a possibility to have an interrupt at any point of time, right? Based on the programs, based on the resources, what we're gonna allocate, it depends on that. So interrupt driven as being mainly classified into two different types. One is all about the hardware interrupt. One is all about the hardware interrupt, and another one is all about the software interrupt. Hardware interrupt is due to one of the devices, and software interrupt is due to exception or trap. As I said, the exception. We talked about exception on the previous class, like what exception is all about. We also say that what is the difference between the exception and error. We talked a lot of examples about exception, like arithmetic exception, which is one of division by zero, null pointer, and any and lots of other exceptions also we have seen. And so they have given you. So what is the software interrupt? So a software error at division by zero, a request for operating system service. If I'm going to request the OS for one of the service, right? If I'm going to request OS for one of the service, like for an service, if it denies it, then that's going to be one of my software interrupt. And other processes problem including infinite loop, process modifying each other or the operating modifying each other or the operating system. So once you have the infinite loop, okay, once you have the infinite loop of running, then it is one of your exception, right? Why? Because we are supposed to end up with one particular solution, but we are not doing that, so right? And what is all about, so if one of the process, like let's take P1 and P2, if P1 is modifying P2 or P1 is modifying the OS, then that is also one of your software. Like we talked about exceptions, we also talked about the request if it has been cancelled or denied, in infinite loop, as well as the modifying process with each other, as well as the other operating system is also one of your software. We can call them basically as trap, right? Okay, fine. And you also have dual mode operation, allows OS to protect itself and other system components. So you have dual mode of operations. So in operating system, there are, as I said, based on the top, heading, what we have, OS will have two modes. One is all about dual mode, and another one is all about kernel. I'm sorry, it's not dual, it's user mode. User mode, another one is kernel, right? So then how can we say that whether the particular OS in the user mode or in the kernel mode? We are supposed to specify whether the OS in the user mode or kernel mode, right? So that can be done with the help of mode bit. That can be done with the help of mode bit, right? So provides ability to distinguish when system is running user code or kernel code. We are supposed to know whether the OS is running in user code or whether it is running in kernel code. Some instructions are designated as privileged, only executable in kernel code only. Because we can some of the instructions like for give you an example, like some of the main instructions, right? So they are getting some privilege. Like, I think that they are supposed to run only the kernel mode, right? And system call changes mode to kernel return from calls. So you talk about system calls and system programs, guys. With the help of system calls, we can change the mode from user mode to the kernel. So one of the important operation is the dual, right? Then increasing CPU support multi-operations. We'll use the virtual machine managers, the VMMs mode for guest VMs, right? So the virtual machines, right? Yeah, the transition from user to kernel mode. What I'm saying. So as I said, let's talk about it. If your mode bit is equal to one, then your OS is said to be in user mode, and when your mode bit is gonna be equal to 0, then we can able to say that OS is the kernel mode. Okay, so let's see. So I'm gonna have a user process executing, and if I'm gonna system call, the system call is gonna have a trap, and I'm gonna make sure to change the mode bit from 1 to 0, and I'm gonna execute the system call. Why? Because the major important thing is your some of the designated system calls what we have. Some of the designated system calls should run inside a kernel, right? But if I want to give you an overview that all of the system calls what we have can be run only inside the kernel, right? So for each and every process is executing, a kind of system call should be executed. So for that point of view, what happens is nothing but the user processors will make sure to transist the user mode to kernel mode so that the system call has been executed inside the kernel. And after executing the kernel, you are supposed to change the mode bit from 0 to 1. And what you have done is you have changed the mode from 0 to 1, and then you have moved to the system call. Right? Clear? This is how the transition from user mode to kernel mode has been done. So what is all about which is given over here? Timer to prevent infinite loop, process hogging resources. Yes. So we are supposed to have a timer in such a way that we to prevent the infinite loop. Yes. So if the timer is set to interrupt the computer after some time, why? Because let's talk about that. Let's talk about that. When we are talking about when we are using recursive functions in our daily programming, so we say that there should be two conditions. One is base condition, another one is recursive condition. If the base condition is met, then the program will end and will come out of the function. If it is not met, the recursive condition will run. If you don't, so let's case a condition that if you don't have a recursive base condition, then the recursive function will run for infinite number of times. So what happens is nothing but it runs for more than infinite time. So what I'm going to do is nothing but I'm going to set timer in such a way that at the 100th iteration or the 100th function call, I'm going to make an interrupt to the particular recursive call and I'm going to come back. Or I'm able to say infinite rule at some time you may be able to get a particular iteration that is being stopped. So that particular point of time a timer has been set and you can able to see the OS has been got an interrupt at a particular point of time. Clear? Okay, so then let's talk about so far we talked about the operating system structure, the operating system operation is all about. Now let's talk about the process management. So now let's talk about some of the management controls like process management, memory management, other things. I'm gonna go as quick as possible, why? Because this is all just an overview about it. While you're talking about lot about process, the life cycle of process, you are supposed to know about it, right? So you know that I will give you what can I say, a definition of what process is all about, right? To give a definition of what a process is all about, let's give you an instance over here. Let's see. Let's say I've already shown you what is in programs. You all guys know about what is program. Am I right? You all guys know what is program is. A program is a set of instructions which is used to run a particular task. Which is used to execute a particular task. A process is a program in execution. At particular point of time, what process is being executed, we are supposed to know, right? At particular point of time, what process is being run. So, what point is being run, right? We are supposed to know those things. Then that is going to be called as process. It is a unit of work within the system. I wanted to give you an overview about it. It is a unit of work within a system, and the program is a passive entity where the process is an active entity. You are guys supposed to know those things, guys. Okay, the program is a passive entity. The program is a passive entity, and process is the active entity. Clear? The process is the active entity. You are supposed to know those things. Then the process needs resources to accomplish its task. Yes, I do know about it. And what are those things? So we need to have a CPU. We need to have a CPU, memory, and IO files, and we are also supposed to have the initialization data, right? And the process termination requires reclaim of any reusable resources. Single-threaded process has one program counter specifying the location of the next instruction to execute. You guys know about it. Now let's talk about that too. Okay, I'll also explain those things. Let's have a set of processes. If process number one has been executed, you will have a program counter. As I said, program counter will keep track of the number of number of times of execution which has happened inside one single program. As well as the program counter will also have the address of the next process to be executed. Address of the next process to be executed. Clear? Address of the next process to be executed. So the process executes instruction sequentially one at a time until it's the completion. Yes, we do know about it. Only when the process one is get completed, then after that program counter will point to the next process number two. Then the process two will get executed. Okay. Multi-thread process has one program counter per thread. So for each and every thread, you have one program counter. And typically, systems has many processors, some users, some operating system running concurrently on one or more CPUs. You can also have concurrent processes too, right? So what are the activities which is being covered inside process management? I wanted to go you much deeper, much faster, guys. Why? Because we're not going to talk. We're going to talk. As I say, we're going to talk a lot about this process, those things, right? We're going to talk a lot about the process. We're going to talk a lot about the process. So the major thing is all about what are the activities which is being followed inside the process management. The first thing, creating and deleting both user and system process. Yes, I am supposed to have both user as well as system processes in suspending and resuming process. Why? Because one of the process has been suspended due to the unavailability of IT resources like input and output devices. And after finding the input and output devices, we are supposed to resume the processes too, and we have to provide the mechanism for process synchronization. Don't feel, guys, we're going to talk a lot about process synchronization in the unit number two while we are talking about process. Why? Because synchronizing process based on which process comes first and how the multi-process core is going to happen, we are supposed to know those things too. And providing mechanisms for process communication. If both process one as well as process two gets communicated with each other, then we are supposed to know those things too. And providing mechanisms for deadlock handling. We talk about what deadlock is, right? Deadlock is nothing but if one process has been allocated in the CPU and the process two is waiting, then we can make sure that process one, what happens, nothing but this does not get executed at all, does not complete its execution at all. So the P2 has to wait until the P1 gets completed. So a kind of deadlock has been handled, and now we are gonna deadlock has been happened, and we are supposed to know how we are gonna handle. We're gonna talk a lot about deadlock handling, and with the help of an algorithm, we are gonna see about what deadlock is all about. Right. So now process management is done. What is memory management? As I said, so we are supposed to execute all the programs or instructions should be in the memory, and we are supposed to that in memory. The memory it should be in the main memory, and if it is in the secondary memory, we have to transit the instructions from the secondary memory to the main memory, so that the CPU has direct access to the main memory, right? And memory management determines what is in memory and when, optimizing CPU utilization and computer responses to the user, and what are the activities of the memory management. So, which keep track of which part of memory are currently being used and by whom. Like you have lot of, if I have a single part of memory, which part of memory which is being used by which part of memory is being currently being used and by whom it is being used, and deciding which process and data to move and in and out of memory, which process has been moved, and allocating and deallocating memory spaces as needed. Right? Okay, that's all about memory management. And as I wanted to give you about storage management to give you as right, whether you're going to store inside a logical storage unit called as file, or if you're going to store inside in a medium called as hard disk drive, tap drive, disk drive, etc., and etc., and etc. And file system management depends upon it, and it also includes creating and deleting files, primitive to manipulate files in directories, mapping files onto secondary storage, and you can also have an onto stable non-volatile storage medium, which doesn't delete your file if your computer is being switched off, right? Okay, and a mass storage management. So, what is a mass storage management? If I'm gonna usually this used to store data that does not fit in the main memory or data that must be kept for a long period of time. Yes, I mean to show we are supposed to have we are supposed to have it for long period of time. So, proper management is of central importance. So, what we are supposed to do for a mass storage management, if you're gonna store for a long period of time, we are supposed to get into the disk that which does not fit into the main memory. So what are the activities based on that? So first and foremost thing is free space management. So you're supposed to check whether it's in any free space, and storage allocation, and disk scheduling. Right? We are supposed to know about the disk scheduling too. Right? And some storage need to be fast. Like tertiary storage includes optical storage and magnetic tapes still must be managed. Okay, even though it is far fast, we are supposed to manage. The O is supposed to manage and varies between WORM, WORM, and RTW. Right? WORM is write once, read many times. RTW is read write. Right? So we are supposed to write once and read many times and read in. Right? So we are supposed to know those things too. Okay, so this you guys know, and I don't want to talk a lot about it. And how we can do it. So how we can what can I say, migrating of data A from disk to the register. As I said, once you have seen the hierarchy of storage management, the first and foremost thing is register, and next you have seen about caching. Next you have seen about one more important thing. Then you have seen about main memory. Then you get into the hard disk. Somewhere you have SSDs in between. Am I right? Somewhere you have SSD in between. Okay. Now you are supposed to move your data from hard disk to the register. So suppose what you have to do, you are supposed to move to the main memory, then you have to move to the cache, and you are supposed to move to the register. It should be hierarchical. It should be following your hierarchy of storage what we have seen so far, right? Okay, right, sure. Okay, okay. Let's talk about the IO subsystem. So you talk about the IO subsystem in the next conservative classes, guys. Why? Because it's gonna repeat. Why? Because in the second a part of overview, you're gonna talk a lot about that. Okay, the IO subsystem is right. Now, what is the protection and security? You guys know about what is protection is. We are gonna make any mechanism for control access of process. Why? Because we have one process number P1. We are supposed to control the access. Who and all going to access the processes, right? We do have a gateway in between. That gateway will make sure that only with the user with an ID, other process with an ID, this ID can be allowed to use the process, or else not. And security, like you have a defensive system against internal and external attacks. You have distributed denial of service. DDoS is nothing but creating multiple requests from one single user, which can make the server or which can make the process, which can make the CPU dead, or which can make the CPU dead or get crashed. Right? So make sure we are supposed to know those security measures before getting into it. System generally first distinguish among users to determine who can do that. First one is user identities, user IDs and security IDs, user ID and group ID and privilege escalation, which allows user to change to effective ID with more rights. If you're going to change your IDs, you're supposed to go for the privilege escalation. Right. Okay. Now let's talk about the data structures which is present inside kernels. Right. Many similar to standard programming data structures. First and foremost thing, I don't want to give you an overview, right? Because since you are some of the people do know about some of the data structures, some of them don't know, right? So if it is needed, we can provide another masterclass like this, a preparation series like this. We'll ask for a complete data structures part to explain each and every core data structures which is present over here. Okay, first and foremost thing which is present, one of the important data structure in kernel is linked list, right? Which is have links from one node to another node. You don't want to store them in one single in a contiguous array, a contiguous memory location. You can store that in the different memory location, and where the links in the second node, the address of the second node will be mapped accordingly. There are a lot of different types of linked lists. You have single linked list, you have doubly linked list, and you have also have circular linked list too. Right, you guys know about it, and I'm gonna skip as much as possible. And you have binary search tree. Binary search tree, the BST format. You guys know about it. If I have 17, 12, 6, 14, 35, 32, and 40. So there is some difference between binary tree and binary search tree. Am I right? So binary tree is all about having at most two chunks. But binary search tree is nothing but BST is nothing but it also have at most two childs. But the thing is, the left is always less than or equal to right. The left is always less than or equal to right. That means the parent node, the parent node always less than or equal to so our parent node is always greater than or equal to right. Sorry. Okay. Wait, sorry. I'm sorry, guys. Wait, sorry. The parent node always greater than right in the parent node always less than it should be left, guys. Sorry, I'm sorry. Parent node is always greater than left and it should be less than right. I'm sorry, guys. So this is the condition over here in BST, right? You should not, you can it is same like binary tree, but you are supposed to fulfill this condition. And the search space in binary tree is gonna be big O of n, and in a balanced binary search tree it's gonna be big O of log. Then hash function, you guys know about it. Hash function is the thing which stores you the frequency, and you can also have the hash map to show us to store the frequency of each and every element. So which can also help us, right? And bitmap and Linux data structures which include Linux list.h, kf4.h, and rb3.h. So kf4 is nothing but first and first start, which is nothing but your first and first start. Very good. Q and RB tree, right? You also have the trees too, right? So, what we go view with computing environments. So, what is traditional thing? So, in the traditional thing, we do have network computers like web terminals and so there are lot of evolution in computing environments, right? There are a lot of evolutions in computing environments, and there is also mobile environment like you now. Right now, we are using augmented reality in the mobile world, like Google Android, Apple OS. Now, more than that, we don't have any other operating systems. If I'm not sure of that, so one of the two important leaders of mobile environment is Apple, and the one is Google's Android, right? And distributed. If you're gonna be a distributed computing, then we're gonna have lots of communication path in between, and TCP IP is the most common thing. You have LAN, you have WAN, you have MAN, and you have PAN. Local area network, wide area network, metropolitan area network, and personal area network. I think you guys know about it. If not so, we'll get into the part of it. Right? Okay. Then, what is all about the computing environment? The client server computing. I think so you guys know about it. Let's talk about that. If I'm gonna have a client like desktop, laptop, and smartphone. they want to access the server. How can they access? Only with the help of network what they have, they can able to access the server, so that if the client gives the request, if the client gives the request and the request is being processed by the server, and the server will give the response back to the client. The server will give the response back to the client. Clear? The server will give the response back to the client. So this is gonna be the communication gateway. Like the request and response is going to be the what can I say this gateway. So you have computer server system provides an interface to client to request service. You can also have file server system with where inside the server we also have some files where we can able to access it. Now, peer to peer, right? First thing we talked about client server model. Then what is peer to peer? Peer to peer, P2P is nothing but mutual communication. If I want to give you an overview, the mutual communication. What is mutual communication? Let's see the diagram over there, which is given there. There are totally five clients. Each and every client is being associated with each and other clients, right? Because not like a client or server. That means there's going to be a server, and each and every client is going to access. Not like that. Each and every client has been associated with each and every other server. It's kind of distributed system. So examples are Napster, Nutella, VoiceOver, IP, such as Skype is also one of your peer-to-peer model. Virtualization, very, very, can I say, like if I want to give you an overview about virtualization is, if I want to say that thing, virtualization is gonna be the future of your computing environments. Why? Because right now virtualization is done, which is there in terms of cloud computing. So allows operating system to run application within other OSs. And virtualization, nothing but you're gonna virtualize something, you're gonna run your applications in other operating systems, right? So I don't want to talk a lot about it. Why? Because virtualization is somewhat what we have said so far, allowing operating system to run your application within other OSs. And you also see the last point. OS natively compiled for CPU, running guest OSs also natively compiled. Okay, consider VMware running on WinXP guest, each running applications on our native WinXP OS. So VMware is nothing but a cloud, right? So VMware, where one of the virtualized CPU vCPUs I can able to consider, I can construct, and so that it can start working, and I can run my application and run my own OS inside that thing, right? So which one is going to give me the virtualization services? The virtual machine manager is going to provide me the virtualization services, right? So then we also have the computing environment. The use case involves laptops, desktop running on the multiple OSs, multiple OSs. Sorry, guys, multiple OSs for exploration or compatibility. This and all just an overview about it, and I don't want to push you much. And the king, the cloud. So if I want to learn a lot about cloud, as I said, and I'm the AWS cloud captain, and my preferred domain is all about MLOps, which is I'm working with machine learning with cloud computing. So I thought that cloud computing is going to be the future. Why? Because each and everyone depends upon the resources. Like they're supposed to have the kind of resources needed for their running for building their application. But cloud computing provides in such an easier way so that they can use their resources and on-demand delivery of IT resources. And there are a lot of types, like you have private cloud, public cloud, hybrid cloud, and there are lots and lots of deployment models like SaaS, lots of types of services which is available in cloud, like SaaS, PaaS, and IaaS, which going to help you a lot. Right. Okay. In the real-time embedded systems, guys, and let's talk about the open source operating system. So, what is open source operating system? Open source operating system is nothing but you have a lot of other now like so far we are running two operating systems in a hand. One is Windows, Linux, and so yes. So there are two operating systems we are running so far. We have Windows, Linux, and macOS. Yeah. So far I'm using Windows and Linux, but I'm not fond of macOS. But each and everything like your Windows as well as your macOS are originated from Linux. Okay, it's nothing but the GUI version of Linux, right? That's it. So there are a lot of things, guys, to get endowered. Okay, so we talked a lot about it, and that's the end of your like the overview, the part one of your overview of operating system. So thank you for watching. Keep get notified and subscribe to the channel so that we'll see the second part of an overview. That means we are gonna get it. So the introduction to operating system is being done, so we have completed the introduction to operating system. Now we are going to move into the system operation. We're going to talk a lot about system calls, system programs, and how the bootstrap programming, booting is going to happen. So we're going to talk a lot about that. So it's going to be interesting. So once we're done with that thing, then we can move to the processes, and we're going to get into the much wider sessions, which is nothing but your algorithms too. Right, so thank you for listening, and subscribe to the channel for more videos. And as I said, I'll ping my first video regarding what is operating system and about what interrupt is all about in the description box. So feel free to check, and thank you so much.